We are going to discuss about distribution. Okay, so today I am going to, because you all know that there are two types of distributions. First is discrete and the second is continuous. But right now in today's class, we are going to discuss about discrete distribution. So this is a very basic class that I am going to give. So first of all, obviously a first question arises here, like what is distribution? So is there anyone who can tell me about it? What do you think by this name distribution, what it defines? Is there anyone who can tell me? If you have an idea, you can unmute yourself, you can let me know. If you have no idea, you can press thumbs down button. I will explain it to you. Anyone who can tell me what is the meaning of distribution and specifically discrete distribution? Anyone? Jaren, Sangeeta, Anayat, Neha, Vijay, Tanishka, anyone who can tell me about discrete distribution? Like what is discrete distribution? If you have no idea, you can press thumbs down button. Am I audible to all of you? Okay. Okay, so no problem. So I'm telling you, basically discrete, what is the meaning of discrete? Discrete means countable. Countable means the thing that you can list one by one. That means the things that you can count one by one, right? So a distribution tells us how likely each value is, right? So it just simply means a discrete distribution is like that. We are talking about the situation where outcomes occur are countable numbers, not like a continuous thing, like a height and weight. It is not like height and weight. It is like a countable number, like the number of apples in a cart, you can say. There are some other examples also, like you can say the number of telephones, like the number of telephone calls happening from between the time 12 p.m. to 12 p.m. to 1 p.m. you can say, 1 p.m. to 2 p.m. you can say. So these will obviously be a countable number of calls. Okay, so we are focusing here the events which are countable in number, and we can attach a probability to each possible outcome. Remember what I said? We are interested in the events that are countable in number, and also along with that we can attach probability to them. Okay, so in a very simple language, if I am telling you about an example of rolling of a dice, okay, if we are going to roll a dice, what we can say, how many possible outcomes are there of a dice? This is the notation that I am using to represent a sample space, and in a sample space we always put the outcomes and all possible outcomes, right? So obviously if you are going to roll a dice, you will get either 1, 2, 3, 4, 5 and 6, right? So there are total 6 possible outcomes, and we can attach probability to them. How we are in a form of a discrete distribution or a PMF, how you are going to write this experiment of rolling of a dice. You will write that X is taking value 1, 2, 3, 4, 5, 6, and what is the probability that you are going to attach to them? That means what is the probability of happening 1? Everyone let me know quickly, what is the probability of happening 1? What we should write? Write down your answer in the chat box quickly. Okay, and I said 1 by 6. In the same way, what is the probability of happening of event 2? Correct, Jaren. See, 2 is occurring only one time in the sample space. No, Sangeeta, 2 by 6 is not correct. We have to use the concept of, if you want to find the probability of happening of an event. Like this is what we usually study. We usually study in the chapter number 3 from the book Gupta and Kapoor, like how to find probability of happening of any particular event. So this event is saying that the probability of happening of the event 2. Right, so that means 2 is occurring in the sample space only one time. So the formula that you have to use is favorable case upon total number of cases, right? So now from here what you can say, 2 is happening only one time in this whole sample space, so favorable case is only 1, not 2. We are counting the numbers. Okay, we are counting the events. Consider these are only events. You can also say this is your A1, this is your A2, this is your A3 up to A6. So I am asking you, okay, just wait. Let me see who is in. Okay, so what I said, what, just 1 second. What I said is that what we are doing here, we are just counting the number of events, right? So I am talking about the event A2 and I am asking you that what is the probability of happening this 2. So you can say this A2 is representing the 2 outcome in a case of rolling of a dice. So 2 is happening only one time, right? So that means favorable cases is 1 here. And how many total number of cases do we have here? So obviously it is starting from A1 to A6. So counting it 1, 2, 3, 4, 5, 6. So we have total number of cases are 6 here. So that is why the probability of happening the event 2, or you can say the probability of happening of event A2 is also 1 by 6. In the same way, if I am going to ask you that what will be the probability of happening of event A3, right? So A3, like you can see, A3 is the event 3 and event 3 is occurring only 3 times in this whole sample space. So favorable case is 1 here and total number of cases are 6 here. In the same way, we know that in a case of rolling of a die, every number is unique and we have only 1 to 6. So that is why the probability of happening of 4 will be 6. The probability of happening of 5 will be 1 by 6. The probability of happening of 6 will be 1 by 6. Suppose if this is another case where in a sample space we have like 1, 2, 4, 2, 1, 7, 3, 4, 2, like that, right? So these are the events we have. Now what I am going to ask you, so first of all we have to write down the values of x. So right now you can see x is taking how many values? It is taking 1, 1. We have 1 2 times, so I can write 1 only 1 times in your probability, in your x, right? This is the PMF that I am writing here. Now accordingly, after 1, it is also taking value 2. It is also taking value 3. It is also taking value 4. It is also taking value, no, 5 is not given. 6 is also not given. 7 is given to us. So x is taking only these values 1, 2, 3, 4 and 7. Now if in this case I am asking you that you have to attach the probability with every event. So you have to find the probability of happening of this event 1. So if you are getting confused, what you can do, you can give them notation A1, A2, A3, A4 and A5. So now I am asking you what? I am asking you to find the probability of happening of event A1. That means I am asking you to find the probability of A1. So you have to use the same formula. Probability of A is favorable cases upon total number of cases. So right now, what are the favorable number of cases of happening this event A1? Event A1 is representing the happening of event 1, right? That means if you rolled a die and only 1 occur. But right now this is another case where I have taken that it is giving you 2 times 1, right? So favorable cases means you have to, because I have taken the event A1 which is representing the happening of 1. So 1 is occurring here 2 times, right? So we have 2 favorable cases, right? Counting it. This is 1 count and this is second count. So favorable cases are 2 here. And how many total number of cases do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means 2 by 9. So 2 by 9 is the probability of happening of event A1, where A1 is representing the happening of number 1, right? So this is how you have to attach probabilities to them. Okay, now in the second case, I am asking you, like I have given A2 and A2 is the notation that is representing the event 2 is happening, right? So how we are going to find the probability? First of all, you have to count the favorable number of cases. Yes, Anat, you are exactly correct. You have to count the favorable number of cases because A2 is representing the number of 2 happening. So count the number of 2. 2 is happening how many times here in the sample space? 1 time, 2 times and 3 times. So how many favorable cases do we have? We have total 3 favorable cases. And obviously the total number of cases will be the same as we have written here. After counting all the numbers, we have total 9 outcomes, right? So that is why favorable cases upon total number of cases is the probability of happening event A2. Now you all have to tell me what is the probability of happening A3. So everyone please participate and write down your answer in the chat box. What is the probability of happening of event A3? You have to count the favorable number of cases and total number of cases. Okay, Jaren got 1 by 9 and I've got 1 by 9. How many of you are getting? Neha got 1 by 9. Okay, Sangeeta got 1 by 9. Okay, what about you, Vijay? What about you, Arbaz? Okay, Rekha also got 1 by 9. Yes, obviously, we know that we are counting 3. So, favorable case is only 1. So, we can write 1 in the numerator. And in the denominator, we have to write down the total number of cases. Okay, now quickly let me know what is the probability of happening of A2. Quickly everyone, what is the probability of happening of this event A4? A4 is representing the happening of 4. Okay, Jaren got 2 by 9, Rekha got 2 by 9, Neha got 2 by 9. Okay, okay. What about you, Tahira? What about you, Tanishka and Vijay? Amresh, let me know. Are you all getting the same answer? We are talking about 4 and 4 is happening 2 times. So 2 is the favorable cases. Counting. We are just writing down the count of that event. Okay. We cannot put 2 here. We just have to write down the number of favorable cases. There are 2 cases that is attached to this number 4. 4 is here and 4 is here. So there are total 2 favorable cases and total number of cases. As well as for 7, what we are going to write? Only 1 favorable case upon total number of cases. So this is the difference between this example and this example. This is the example where we rolled a die. So that is why every number is occurring only 1 time. And this is the second example that I pick up to explain you if we have the sample space like the same, but numbers are occurring like 2 times, 3 times. So accordingly, you have to attach probability to them like that. Okay, so this is what you have to remember. Now in the same way, if I talk about the real life example, so obviously if I am telling you about the coin tossing, so obviously if I am talking about coin tossing, we know that a coin has 2 sides only, head and tail. So obviously its sample space containing the outcome head and tail only, right? Now what is the probability that you are going to attach to it? So you can say here X is representing head and tail, and what is the probability of happening of head? Favorable case is 1, total number of case 2. Favorable case for tail is 1 and the total number of cases is 2. Right? So you can see here everyone, you can see we are getting the same probability. We are getting the same probability for 1 and 2. Okay, now after that, the second real life example would be the number of kids in a family. So obviously suppose you have a family where you have total 4 kids. So you can write down the number of X, it will take value. Obviously there are many possible cases, right? So I am just taking a general example where I am counting the number of kids in a family. So if I am considering suppose 10 families. So in this 10 families, there are how many possible outcomes there? It can happen that there would be no kids in that family. It can also happen that in a family there is a 1 kid. It can also happen that there are 2 children in that family, up to ... It can also happen that there are like many children in a family, right? So X will take possible values like 0, 1, 2 up to ... So in the same way, you can also find the number of, like you can also attach probability to them, right? So there are like various real life examples that you can consider. Okay, now after that, we are like this is just the general explanation that what is distribution means and how it works and how can we attach probability to them.